Jai Hind all. Myself Amita Asthana from Ajay Kumar Garg Engineering College, Ghaziabad. Here in this video lecture, we will have the important topic from Unit 4 defined in the syllabus of DST KEC 302, that is PAL and FPGA. So PAL is nothing but programmable array logic and FPGA fixed programmable gate arrays. These two topics we will be covering in this video lecture. So here let us understand the difference between the PLA and the PAL. In the previous video lecture we have already discussed about the PLA, that is programmable logic array. In that we have made the circuit using AND gate and OR gate. Both the circuits were programmable in the case of PLA, as we have already learned. Whereas in the case of PAL, we have the AND arrays are programmable, but OR arrays are fixed. Okay, so that means the AND array is going to be programmed according to the expression obtained by simplification of Boolean expression or by K-map. But the OR gate arrangement is fixed in this case, and that is the important point for this. So the difference between the two is very visible in the slide. So here the OR gate is programmable and the OR gate is fixed in the case of PAL. So here we are going to discuss this PAL arrangement, how to make it. Let us take an example for BCD to X3 code converter using PAL. Let's say we have a question that convert the given BCD to X3 using PAL, realize using PAL. This BCD to X3 code converter using PAL. So we have the BCD codes and X3 codes. So here the B3, B2, B1, B0. So the BCD codes we have written for all the circuits, like we have written 0, 0, 0, 0, 0, 0, 0, 1, same as usual, or you can write it as 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, like this. And here 2 zeros and 2 ones, 2 zeros, 2 ones, 2 zeros, 2 ones, like that. 4 zeros, 4 ones, 4 0, 4 ones, 4 and 8 zeros and 8 ones. So here after completing this B0, B1, B2, B3, we can write the X3. So X3 code for B3, B2, B1, B0, the X3 code is defined for 0 to 9. So here the add plus 3 to this, and we can get the X3 as 0, 0, 1, 1. For 0, 0, 0, 1, we will add again 3, that will come out to be 0, 1, 0, 0. And for 0, 0, 1, 0, we will add 3 to it, we will get 5. So we will write 0, 1, 0, 1. For 0, 0, 1, 1, we will be writing 0, 1, 1, 0. And similarly, we will complete the table up to here, up to 9. So up to 9, we will complete the table and we will convert the X3. All rest, these are not defined for the X3 code converter as we know already. So here we will put all the don't care conditions for the remaining codes. So since we have from 0 to 9. So first of all, we will write the conversion table from BCD to X3. Now let us, using the K-map, we will obtain the expression for E3 in terms of B0, B1, B2, B3, expression for E2 in terms of B0, B1, B2, B3, expression for E1, and similarly expression for E0, right? So we will get all the expression in terms of input variables. So we will make a K-map. So writing it B3, B2, B1, B0. So here we can write it as B1 bar, B0 bar. Okay. And here we can write it as B1 bar B0 and this B1 B0 bar, B1, B0. Similarly, we will write here also B3, B2 bar, B3 bar, B2, B3, B2, and B3, B2 bar. Let us make the table for E0. So writing the min terms, E0 is 1 at 0, 2, 4, 6 and 8, and the crosses are for the all these D don't care conditions are for 10, 11, 12, 13, 14, 15. So all our don't care conditions, we will fill it up. Filling this. So 0, 2 and 4, 6 and then 8. Okay. After that, put don't care for 10, 11, 12, 13, 14. So we are obtaining one quad. We are obtaining a quad here. So we will, octet. We are having one octet. So we will write the expression for this octet. And this comes out to be B0 bar. So E0 is coming out to be B0 bar. So this is my expression. Similarly, we will solve for E1, E2 and E3 by using the K-map. So all the expression, after solving all the expression using the K-map technique, we can get the expression like this. So we have obtained the expression, 4 outputs and 4 inputs, right? E0, E1, E2, E3 are the 4 outputs, and these are B0, B1, B2, B3 are the 4 inputs. Now, for making the PAL configuration, we decide number of inputs first. So what are the number of buffer inputs? As we have seen in the case of PLA, number of inputs were equal to the number of the buffers, input buffers. So here also we will be using number of buffer inputs as 4, because there are 4 inputs, B0, B1, B2 and B3. So we have got number of buffer inputs as 4, number of buffer inputs, as I told you that this will be a buffer input. If I give B0 here, then it will be giving B0. Okay, like this. Now, same number of AND gates. Number of AND gates. For deciding number of AND gates, we need to see what are the fixed number of OR gates for each NAND gate. That means here we are fixing, as already I told you, fixing the OR array. So in the case of PAL, we are fixing the OR array. If we are fixing the OR array, so what should be the number of AND gates for each OR gate, right? Since I have 4 outputs, see, I have 4 outputs. So I will have 4 OR gates, right? And after that, deciding the number of OR gates, I can take the number of AND gates. Now, next part. See the min terms here. What are the maximum count for the min term for each output? So here we are having 3 expressions. In this we are having 2 min terms, and here we are having 2, and here we are having only 1. Okay. That means I mean to say 1, 2 and 3, 1 and 2, 1 and 2 and 1, right? So that means at least 3 AND gates I will take for each OR gate. At least 3 AND gates I will take for each OR gate. That should be clear for PAL. And this is how PAL is different from PLA. In the PLA, we are not calculating number of AND gates in this way, but here we are calculating number of AND gates, and which should be permanently connected to the OR gate individually. And here we are fixing that 3 AND gates are needed for each and every OR gate, and that is how the PAL can be designed. It's okay. So let us make this circuit. So what we can do is, we will first of all make the buffer inputs. Inputs are V0, V1, V2, V3. We will mention here. Four OR gates. Each OR gate is having 3 AND gates. That means we need to make 12 AND gates. Okay. Now 4 OR gates I should have. I will make it here better. So 1, these OR gates I am making for, see, E0, E1, E2, E3. So these three AND gates, 1, 2, 3, 1, 2, 3. These 3 AND gates are for E0, and these 3 AND gates are for E1, these 3 AND gates are for E2, and these 3 AND gates are for E3. Now let us complete the circuit by making all the connections. So here so E0. see for E0 what we can, these E0, how to mention this, that this is fixed for okay, and these are for this is a fixed OR gate kind of arrangement, that I have fixed these three inputs to my OR gates. So this is how this PAL is different from PLA. So now let us coming to the expression. So I will give the expression E0 for from these three AND gates, because this E0, these three AND gates are belonging to the E0 input. So E0 is B3 plus B2 B0 second plus B2 B1. Okay, so this is a PAL arrangement. Now for even, for B2 bar B0, B2 here we have made the wrong entries. This is, let's say this is for E3, this is for E2, let's say, and this is for E1, and this is for E0. We can adjust, I have just reversed because of this E3 is connected and I have made the connections for this one. Now coming to the E2, similarly we will write B2 bar B0, B2 bar B0 and B2 bar B1. So B2 bar and B1. Okay, here only these two gates have been utilized there, and this AND gate is spare, that is, this is extra. Now coming to the E1, B1 bar B0 bar, and B1 B0. Again here these two are under utilization, but this is extra. So this gate is not being utilized by any OR gate. Similarly, E0 is B0 bar. So here this E0 is B0 bar only this has been utilized, but these two are extra. So in this way we can make the PAL structure. Only the thing is that all the AND gates are used for, fixed AND gates are used for OR gates like this, and this is how the PAL is different from the PLA. Now coming to the here one more example is being given. Let's say we have one 4 variable function w, x, y and z. 4 functions are here. We can write the expression and we can solve the K-map. We can get the expression using these min terms, and after obtaining the expression we can just make the table and get the expression. Here also in this we can see that few AND gates are not being utilized by any output, like x is not utilizing this AND gate and w is not utilizing this AND gate. This is the only difference. So here the next topic is being fixed programmable gate array. So the fixed programmable gate array is nothing but an array of few integrated circuit which can contain 64 to 10,000 logic cells. So here you can see in this particular diagram that we are having the logical block, and this is one input output block, this is also input output block, and you can see these blocks are repeating with each other. So here this is a logic block, this is a logic block, this is a logic block, these are the logic block. So all the logic blocks are same, and these are the connectivities between the logic blocks. These dark squares, filled black squares, are nothing but the connectivity between the logic blocks, and these are connected to input output blocks. So here these logic blocks are same. This circuit is same as this circuit, this circuit is same as this circuit. That means we are repeating the blocks and interconnecting them in such a way that our application can be fulfilled. So here the maximum and minimum number of these blocks to be contained in a chip, that is 64 to 10,000. 64 is the minimum and 10,000 is the maximum. So each logic cell is independent and can perform any defined function. Individual cells are interconnected by wires and programmable switches. These are actually the interconnections, or these are the switches. These are switching modules which are connecting these logic blocks. So field programmable arrays are meant for users program, and they are not at the part of manufacturer. That means if the connections and the logic blocks are being given, the user can utilize it according to the application, right? Here the expansion of the same thing, that here again the configurable logical block. Each logic block is known as CLB, that is configurable logic block, and these are known as switch matrix, and these switch matrix are being repeated to provide interconnections between the CLBs. Okay, and each and every CLB can have inputs from 3 to 10, and they can perform any specified Boolean expression. They can be connected, and these all CLB within FPGA is same. They are same. So the circuit for defined circuit is here. The inputs, let's say we have x1 to x2, whatever the function in terms of x1 and x2. So these are the functions, these are the connectivity switches, the wires have been shown, and the cells combinational logic can be physically implemented by the lookup tables. Lookup tables are defined for every memory switch, and from the lookup table the connections can be managed. There are various applications for the FPGA, that is random logic, integrated multiple, SPLDs, device controllers, communication, encoding, filtering, and large hardware systems. So this was a brief introduction about the field programmable gate arrays. Thank you.